In this video, I'm going to be talking about the Timing Project Manager. This file defines the start date, number of shifts for the mine plan. We're going to define equipment specifications. We're going to define a working calendar. I'm also going to talk about attribute groups and drawing events. So we're going to be diving into all the details of these steps. Before I show how to edit the Timing Project Manager, I just want to quickly show how we can specify the file to use. If I go to the underground pull-down menu, you'll see the second command here for Timing Project Manager. If I've not yet created one of those files, running this command will prompt me to create a file. You may recall in one of the previous videos, we actually had to go ahead and create one of those files as somewhat of a placeholder for the command we were using. So I already have a file created. If you're not sure if that file has yet been created, we're going to take a look at the mining project settings. And you can see here that we do have a Timing Project Manager file is configured. It's associated with the drawing. So anytime I edit the Timing Project Manager, it's editing that file right there. Now, it's not very common to create multiple files for a drawing, but if you wanted to, you can always click this button and specify a new file here. For the time being, I'm not going to. We're just going to stick with the file that's already been created. So now let's show what's actually in that file. I'm going to go back to the underground pull-down menu, Timing Project Manager. And again, you can see the file name is listed up here at the top. So this file is primarily a tree structure with multiple branches showing for each element, and there's also some settings down here at the bottom. Now, the first thing that we want to define in our Timing Project Manager is just going to be a mining start date and the number of shifts. You can always change these later on, but this is the first thing we need to specify. I'm going to click this little button here. This will show a kind of calendar selection. And I'm going to back this up. Let's set the mine start date to January 1st of 2021. Enter date, we're good to go. The next thing is going to be the number of shifts. So Carlson supports up to 4 working shifts. I do want to mention that just because you have 3 or 4 working shifts, it doesn't mean that equipment's going to be working all of those shifts. So if you allow for 3 shifts, but maybe on the weekends you only run 1 or 2 of those, you still need to go ahead and enter in 3 shifts because that's the most that you could have at any point in time. So now with those 2 items defined, let's take a look at this kind of tree structure. So there's really only 3 parts of this tree structure that have to be modified or entered for a kind of a bare minimum run. That is the equipment, the calendar, and the attribute groups. Everything else will be populated automatically or it's optional. So let's start off, let's take a look at the equipment. Notice that there's no branch underneath the equipment here because I haven't added any equipment yet. So I'm going to come over here and click Add Set. So there's a concept of an equipment set, and within that set you can have multiple units, and the units are the actual equipment that's running. So at any given time, you can only use a single equipment set for the timing calculation. So for a lot of applications, users will just have a single equipment set. You might have multiple sets if you wanted to do a what-if analysis and quickly jump back and forth between the different options. But for right now, I'm just going to create one, and I'm just going to call it Set 1. So that defines the set, and this takes us to a new dialog where we can actually define the units. Let's go ahead and add a unit. I'm going to click the Add button, and I'm going to give this unit a name, and I'll just call it CM1. The next part of the dialog defines our unit of production. So we can see down here, this is where we're actually specifying the values, but these options are telling us what do those values represent. So for example, our first line here specifies the advance rate per shift. It's at a value of 600. With this current configuration, it's telling it that this unit is going to mine 600 tons per shift. Similarly, I could change that. I could say I want to specify a advance rate by a distance. So I could say 600 feet per shift. There's also an option to specify the cubic yards per shift, although that's more commonly used for surface mining applications. And there's also the option to define the linear feet of advance, which is going to differ a lot from the distance. Just some more notes on that. The distance option doesn't consider the footage of number of entries and crosscuts. It's just the distance along the length of the panel. So for example, for a long wall panel, you don't have multiple entries, you don't have crosscuts. So it would make sense just to specify the advance rate by the distance. For continuous miners, however, where we have multiple entries, multiple crosscuts as we move down the panel, it makes more sense to specify the linear feet of advance. So just like the distance, here we could say we're going to do 600 linear feet of advance per shift. For right now, I'm just going to stick with the tonnage, and we'll run with that for both units. Moving down a bit, we can see we actually have multiple columns for each shift. So if you wanted to specify a different advance rate for each shift, you can certainly do that. I'm going to keep them all exactly the same, but I am going to change up these values just a bit. Now you can see here I can define the advance rate per shift. A little bit further down I can see the hours per shift, and I can see the advance rate per hour. And all three of those fields are actually linked together. So for example, if I bumped up my advance rate per shift to say 800, it's taking 800 dividing by 8 hours, and you can see it automatically updated my advance rate per hour. Same way, if I wanted to say I'm going to mine 120 tons per hour, it updates my advance rate per shift. Same thing if I was going to change up the hours per shift, so you can just trust that all three of those numbers are always going to be consistent. I'm going to stick with an 8-hour shift, and I'm going to say we're going to do 100 tons per hour, so that'll give me 800 tons per shift. Update that. That's good to go. Now I also have the option to specify the retreat rate per shift and the retreat rate per hour. I'm not going to be doing any retreat mining in this example, but that'll work exactly the same way. So you can specify different rates for advance versus retreat. Moving down a bit more, we can see that we have an availability factor, and the default is 1, meaning it's able to run at that rate 100% of the time. If you were to change this to a lower value, let's say we're only going to be running 95% of the time, all that's really doing is it's just derating this advance rate by that availability factor. So for an easy calculation, if I set that to a 0.5, this is exactly the same as if I had set the advance rate per shift down to 400 and still kept the availability at 1. So most of the time I don't modify that, but you can use that to kind of derate your advance rate per shift if you like. Moving down a bit more, we can say that we have an advance minimum height and an advance maximum height. If you leave these fields blank, there's not going to be any restrictions placed on the mining height for the equipment. So if I wanted to specify the minimum mining height as 3 feet, just based on the physical geometry of the equipment, it's impossible to mine anything less than that. I can put this in, and if my thickness grids for the coal and the rock thickness don't add up to at least 3 feet, the program will automatically add in additional waste material so that it always maintains a minimum mining height of 3 feet. In the same way, if I wanted to specify a maximum mining height, maybe my particular unit can't reach higher than 9 feet, and my coal thickness exceeds that, then the program will automatically leave some coal in the roof of the mine. So it'll never mine more than 9 feet if I have that. I'll go ahead and leave those in place, but I don't believe they're going to be coming into play based off of the thickness grids that I have. Same thing, you can specify those values for the retreat on both the minimum and the maximum. The maintenance frequency and the routine maintenance actually allows you to specify the number of tons or maybe the distance interval on which a delay will take place. So for example, if I wanted to say that every 100,000 tons, I'm going to take a 4-shift delay for some type of maintenance. That's what's expected to be input here. And the same way, the routine maintenance is just another way to specify. So maybe that's every 10,000 tons, I'm going to take a 1-shift delay. Don't see these used as often, but it is an option there if you wanted to specify maintenance based on the tonnage or based off the total distance mined, something like that. So I'm going to clear those out, keep them as is. Other two parts here, the extraction factor will simply say that you're going to recover X percentage of the key material. So if we set this to 0.95, it just means that 5% of the material mined by this equipment is going to be lost in some way. Again, don't see that used as often, so I'm going to keep that at a 1. And then the cost per hour is just an optional field. If you actually input a value here, when you actually calculate the timing, the program will just say you ran for this many hours, this is the rate you entered, so here's the total cost to run that equipment for this time period. Another thing I want to mention here is the Advanced button. This opens up a new dialog, and this allows us to modify the production rate based on 3 different options. So for example here, I have a date-specific difficulty factor. If I leave this totally blank, these 3 options are not going to come into play, and we're going to just use the normal advance rate of 800 tons per shift all the way through the project. Now if I add a date-specific difficulty factor, I can specify an end date. I know that my mine is starting in January 1st of 2021. So I'm going to tell the program here for the first year through 1/1/2022, I want to increase the difficulty factor and actually slow down my production rate. So let's say we're only going to run at half the production rate. So I'm going to put in a difficulty factor of 2. You can see here that the adjusted rate is 400. Again, it's always referring to that advanced rate per shift. So just for the first year of production, I'd be running at this rate. Now, it is good practice to specify the full set of dates that you expect to mine through. So what I usually do is I always add in an extra row that just goes out to a point really far out in the future. So just say that to December 31st of 2099. And I set the difficulty factor back to 1, just so I know that after this date, this is what it's going to use. The program will do that automatically, but I always like to just see it explicitly stated. So with that, you can add as many end dates as you like to speed up or slow down the equipment. Maybe not used as much for underground timing, but for surface applications, when you run into the winter months, this can definitely come in handy. For right now though, I'm going to clear that out. We're going to do normal mining rate throughout. Another way to specify difficulty rate is based on the thickness. So for example, if I say for a thickness up to 4 feet, from 0 to 4 feet, maybe that's going to be a little more difficult to mine because it's a little bit lower coal. Here I'm going to punch in a difficulty factor of a 1.2. I'm not messing with any rehandle. And you can see here my adjusted rate, 666 tons per shift. So change it to a 1.3. We can see that the higher the difficulty rate, the slower the adjusted production rate. Just one way to think of that is your advance rate per shift divided by the difficulty gives you the adjusted rate. We do have a difficulty calculator down here. So you could say if I want my production to decrease by 10%, you would need a difficulty factor of 1.1 repeating. If we changed it by 50%, so we're only doing half the production, that's a difficulty factor of 2. So you can use that just to help you think about the difficulty factors. So just going on with this example again, let's say for a thickness from 4 to 9 feet, that's going to be a normal production rate, no change there. So you can just use this to help you speed up, slow down production just based off thickness of the material that you're mining. Now again, I'm going to clear those out. The third option here we really don't use for underground applications. This is really limited to surface applications, so I won't be talking about that option. With that, we have defined our first piece of equipment, about as plain as we can make it. I'm going to hit OK, and we can see that unit has been created. I can always go back and edit these units later on. This is not written in stone, so you can run the timings, come back here, make changes as needed. And we'll say OK. Now, looking back on the main branch, I can see I have the equipment set and I've got my CM1 unit there. Now, if I'm going to have a second continuous miner, I can actually just highlight that unit and click copy, and it's going to make an exact copy, and it's just going to increment the name. So if I go in and edit it, I can see all the factors that I input there. I've made a copy of it, and if I wanted to make any changes to this specific equipment, I could do that. But that's all we're going to do for the equipment. Next, let's talk about the working calendars. Here I'm going to add a new calendar, and I'm just going to call it Calendar 1. And we can see that this opens up the calendar editor. I just want to mention it's fairly common just to have a single working calendar. You can define multiple if you like to do what-if analysis, but we're just going to edit this one calendar. And by default, our working calendar, we are working every shift every day. So the idea here is to modify the calendar to define downtime to get a more accurate work schedule. I can see up at the top here, I can jump between different years. If I want to turn days on and off, I can jump between the months. I can also use the arrow keys here just to jump between those months and years. And the idea is to write rules to add downtime to the calendar. So I'm going to go to my very first day of production here, which is January 1st of 2021. And I can see on that day I have the 3 green dots. If I see a green dot, it means all the equipment is working during that shift. Now, a very manual way to do this is to actually click on the green dots. You'll see that they turn black. That means it turns off all production for all entities. So if you wanted, you could actually just go through, click off the days that you don't want to work. However, it only affects that one day. So if I were to go to January of 2022, you can see that hasn't been affected. So if I really wanted to assign a holiday here, New Year's Day on January 1st every year, the way I'm going to do that is I'm going to highlight January 1st, and over here on the right, I can see all the options for specifying a downtime rule. So this rule is going to affect all of the entities as opposed to just a specific piece of equipment. And I'm going to say it's going to affect all 3 shifts. It's going to be manually scheduled downtime, and it's going to repeat yearly. This is going to last for an indefinite amount of time, so for the full life of the project. And the label, I'll just say New Year's Day. If you don't insert a label will be automatically created that essentially summarizes the rules that we're using. I'll hit apply. We can see it blacks out those dates, adds it to the list down at the bottom, and if I jump to the next year, we can see that date was also blacked out, and it'll just do that continually. So that's a very simple example of how we can insert a holiday. Let's do something a little bit different. Let's go to the second Saturday, and let's say that starting on this date, every other week, I'm going to take one shift off for maintenance. So I'm going to highlight that day where this is going to start. This is going to affect, let's just have it affect continuous minor 1. And this is only going to affect the third shift. So I'm going to turn off the first and second. This will still be manually scheduled downtime. And for the repeat, well, I'm not doing this weekly, I'm not doing it quarterly, so I'm going to go down here to this every option. And I'll say every 14 days. And again, this will last an indefinite amount of time. I'll click apply, and we can see that every 2 weeks, we're going to have third shift off on Saturday for maintenance. Easy enough. Now, notice here that I'm only selecting CM1. If I go back to all entities, those black dots change to yellow. And a yellow dot means that you have some units are working, some units are not. So, easy way to see if the rule's affecting everything or just a particular unit. So let's define another rule. Let's go to November, and I'm going to define a rule for Thanksgiving. So that's always on the 4th Thursday in November. So I'm going to highlight that date. I'm going to say this affects all entities, all 3 shifts, and this is going to repeat not yearly, but yearly by weekday. This is going to last an indefinite amount of time, and for the label, I'll say this is going to be Thanksgiving. I'll hit apply. Now, a certain scenario is shown up here. It's asking me, is this supposed to be the last weekday of that month, or is it the 4th? So if I say no to that, it will interpret it as being the 4th Thursday of that month. If I say yes, it interprets it as the last Thursday of the month. So in years where you have 5 Thursdays in November, that'll come into play. I'm going to say no to that. Blacks out that date. Now if I jump to the following year, you can see it's really thinking of it as the 4th Thursday. So that's just a couple examples of how you can create rules. But it's also important to note that you can have multiple rules overlapping each other. So let's go back to my example here where I have a rule affecting continuous minor 1, and it's only on that third shift. If I applied another rule that basically overrides this maybe 2 or 3 times a year, I'm going to highlight the first time I want this to occur. So let's just go to April 10th. And here I'm going to say on that particular day, for some reason, I'm not taking that shift off for maintenance. So this is going to affect selected equipment, continuous minor 1, but this time instead of downtime, it's going to be manually scheduled uptime. And this is only affecting that third shift. And I want this to repeat, let's say quarterly. And for the label, I'm going to call it uptime. So you can see here on the 10th, I have 2 events coming into play that contradict each other. The rule here is that the event that is applied last, whatever's showing at the bottom of the list here, that is what actually controls the uptime or the downtime. So I've overwritten that downtime without having to do it one at a time. So I can now jump through my quarters and I would see that uptime rule would override that maintenance. So you have a lot of options in here as far as how you create those rules. And once the rules are created, you can review what you've done here with these different reports. So if I do a rule report, that takes me to my report formatter. Move that up a bit. I'm just going to take a look at everything listed here and we'll display it. And you can see that I've just written 4 different rules. I can see here I've written a rule for New Year's Day, a rule for routine maintenance. I have that uptime. It's kind of overriding the maintenance. And then I've got my Thanksgiving rule. So this is just a quick way to kind of review what's been written, which shifts it actually affects, and which units it's going to affect. So a quick way to review that. I can also do a year report, which is going to tell me when these rules come into play throughout the year. So this is just going to start in January, working its way down, and it's going to tell me the first rule that comes into play is that New Year's Day rule. The next thing is the routine maintenance on January 16th. Just another way to report everything that's coming into play. You could also do a unit report. So this is essentially going to tell me everything that affects CM1 and the date on which it occurs. So just another way you could say I only want to see the reports for continuous minor 1 or continuous minor 2. Just another way to take a look at what you've defined there. So now we've defined both a equipment set and we've defined a calendar. And you'll notice that the headers here are actually shown in a bold black text. I just want to mention if I had created multiple equipment sets or multiple calendars, only one is going to be shown in that bold black text. So for example here, let me add another calendar. And I'm not going to modify that at all. So we just have calendar 1 and calendar 2. So here calendar 1 is shown in bold. That means that's my current calendar. When I actually calculate the timing, that's the calendar that's going to be used. If I want to change that, just highlight the one that you want to use, click Set Current. It's now bold, and now the timing would be based off of that calendar. Also just remove that calendar if I don't need it, make copies of it, things like that. Same thing with the equipment. Okay, so that's our equipment and our calendar. Now the third branch that I want to talk about here are the attribute groups. If I expand this out, I can see that I've got one here. It's just called Underground Example. So that's actually just matching my drawing name. And within that group, I have a default branch. Let's just talk about this set itself. So I'm going to click Edit Set, and I can see here, this is listing out all of my attribute groups. And I just have this default group. The idea with the attribute groups is that you can assign panels to different attribute groups to change things like the mining thickness, the quality of the material that's going to be mined. A lot of different things you can assign there. Let's just edit this default group, show what we can do here. And by default, we just have two attributes defined here, a thickness and a density. So there's some default values in here just so you could basically run a test on the mine plan with a constant thickness of 6 feet, constant density of 80 pounds per cubic foot. But obviously, no mine plan is going to always rely on that constant thickness. We want to be able to define a varying thickness across the property so we get a more accurate model. So what I'm going to do here is, rather than just using this constant value of 6, I'm going to click on File, and I'm going to select the thickness that represents the coal thickness. You can see that that's listed here. I'm going to open it up, and it just lists out that full file name. For the density, I may want to stick with a constant density of 80 pounds per cubic foot. That's all I have to do. And this is really a bare minimum setup as far as what's needed to run the timing, but there's a lot of other valuable information that we can insert here. So let's go ahead and add another attribute, and here I'm going to click this keyword help button. So I can see I've got my thickness and my density, but I also have the option to specify a rock thickness. So that's going to be the non-key material that I'm mining. Let's go ahead and insert that, and I'll pick a file. Now it's important to note here that this rock thickness grid, it will actually mine all of the rock and all of the coal if it's able to. So this is really intended to represent maybe a parting thickness or the amount of non-key material that you know is absolutely going to be mined by that piece of equipment. This is not intended to specify the thickness of a roof layer that might be 40 foot thick, whatever it might be. So just know whatever thicknesses you specify here, all of that's going to be mined if it's allowed based off your equipment specifications. So if I didn't want to specify the rock thickness, I just wanted to take all the coal and let my mining heights determine how much rock I have to take. I don't have to specify a rock thickness here. So I'm actually going to leave it out, and I'll let my 3-foot minimum mining height, 9-foot maximum mining height determine when I actually take rock. So some other keywords that we can put in here. We can see there's an option to specify a difficulty factor. I'm going to talk a little bit more about that in just a bit. There's options to specify different thickness values for the retreat as opposed to the advance. There's a lot of different options we can work with in here. But in addition to this, we can also specify our own attributes that aren't necessarily listed in the keyword help. So for example, if I'm going to specify the heat content of the coal as a BTU, I can pick my file here. I can find my coal BTU grid. It inserts it. So as the program mines through the panel, it'll check all those BTU values and report out my averages. And I can do the same thing for any of the other attributes that I have. So let's just add those in real quick. Okay, so really simple example there. And that's really all I'm going to insert here. I can have multiple attribute groups. So for example, if I had a long wall panel and continuous miner panels, I might want to have a different thickness grid for each of those two types of groups. Alternatively, I might want to have a different attribute group if I was doing multiple levels of mining. So for example, if I've got 2 sets of panels, one for an upper level that's mining seam A, another set of panels that's mining seam B, I could have an attribute group for seam A, an attribute group of seam B, and that's how I would specify the different coal thicknesses for the different seams. So you've got a lot of different options with these attribute groups. I'm going to keep it very simple. I'm just going to use one attribute group total, but I do want to show how we could specify a different attribute group if it was needed. So I'm just going to temporarily add my second one. I'll just call it group 2. And I'm not going to insert anything in here right now. I'm just going to leave that empty. I'll say OK and OK. So I'm backing out of that. So let's say I wanted to add these 4 panels to that different attribute group. The way that I'm going to do that is I'm going to go to the underground pull-down menu, and I'm going to assign panel attributes. Here I'm going to pick the panel polylines to have the attribute group assigned, so I'll just pick those 4. And I can see here I'm going to set a new attribute group, and now group 2 is showing up in the list. I say OK. So now when I run the timing, anything that I've assigned to the attribute group is now assigned to those panels. So that's a really easy way that you can just mass assign different attributes to different panels and make it show up in the timing. Now again, I'm just going to keep mine simple. I'm just going to use a single attribute group. Everything's going to be part of that default group. And that's all I'm going to use. Now, one more thing I wanted to talk about in those attribute groups was the difficulty factor. So there's a few different ways we can specify difficulty factors. And I want to show how we can specify a difficulty factor using a grid file. I'd mentioned in an earlier video that I have some mine hazard areas. So we've got a string channel that we've kind of mapped out, and we expect that when we're in that area, the difficulty is going to be a little bit greater. So we're going to slow our production down by a factor of 1.5. Over in this area, we also have another reason to believe that we're going to have bad roof. So we want to use a difficulty factor of 1.75. Now, earlier I spoke about ways that we could assign a difficulty factor to the equipment based off of a date, based off of a thickness of material mined, but that is equipment based. Whereas here, this is really location based. and the two can be compounded on top of each other. So you can have a equipment difficulty factor and a location-based difficulty factor. I do have a grid file that represents those difficulty factors, and I want to show what that looks like. So I've got one here just called difficulty. I'm going to open it up, and let's turn on the color by elevation. Let's exaggerate that a bit. It's very flat. Let's really expand that out. You can see it's almost just so constant. Any amount of exaggeration, you almost can't even see it. Let's go real big. Okay, that's a little bit better. So we can see here on this difficulty factor, the majority of the grid just has a value of 1. That's all those blue values. The green is right around 1.5 and the red is all up at 1.75. So this is just another grid that I made using grid file utilities, which, and we have another video that talks about that command, where I simply drew these areas, I selected them, and I set the value inside those inclusion polylines to have a value of 1.5 here and a 1.75 down here. So as the program mines through these different panels, whenever it gets into these higher difficulty factor areas, it will automatically slow down the equipment based on that difficulty factor. So in my timing project manager, I'm going to go back to the attribute group, and I'm going to add in my difficulty factor. And now that'll automatically speed up, slow down my equipment based off of those values. Now, while I'm on the topic of difficulty factors, I did want to take just a minute to clarify how difficulty factors will be compounded on top of one another. So whenever we run the timing hour by hour, there is an overall difficulty factor that is applied to the equipment. And like I mentioned earlier, it's a combination of the equipment difficulty factor and the location difficulty factor. In fact, those two values are just multiplied together to give us our overall difficulty factor. Now, the equipment difficulty factor we had already talked about when we were defining the equipment. We had the option to specify a date difficulty factor, a thickness difficulty, and a bench difficulty if you're doing surface applications. And all three of those difficulty factors are multiplied together to give us the overall equipment difficulty factor. For the location difficulty factor, the program actually follows a hierarchy of 3 different options. So the option that I just showed by specifying a difficulty grid in the attribute group, that's actually the medium priority. So there's an option that can actually override this difficulty factor. So inside of every panel, just like when we were specifying the extraction ratio, as we've done here with this blue text, we also have the ability to specify a difficulty factor as a piece of text. And that is as simple as creating a new layer, naming it difficulty, set that current, and I'm just going to draw a new piece of text as an example. We can put this really anywhere in the panel, and I'll just set this to a difficulty factor of 1.2. So that is the highest priority for the location-based difficulty factor. So the program would see that piece of text inside this panel, and that entire panel will use a difficulty factor of 1.2 for the location difficulty. Again, that will override the difficulty factor defined in the attribute group. If you don't use either of those options though, and for the most part you're just going to use a standard location-based difficulty of 1, there is a third option that's lower priority to specify the difficulty. And if I actually go to the Edit Panel command and select this panel, here there is an option to specify the advance and the retreat difficulty factor, and there I could just type in a 1.2. Now again, this is overridden by both of the other methods, so I don't see this one used as often, but it's an option if you're not trying to specify difficulty grid, don't want to have text in the map, and you just want to specify it panel by panel. The next part of the Timing Project Manager that I want to discuss are the drawing events, and these are defined in the settings group. We can see here we have drawing event types. There's a lot of other settings I'm not going to be diving into right now. Drawing event types seem to be the most common thing I see used here. So at the moment, I don't have any drawing events inserted into the Timing Project Manager. Really all these are doing, these are triggers at a certain location in the mine that can assign downtime or basically just allow us to report a certain event when we schedule out the mine. Now before I add anything here, what I really like to do is actually just create a few of those drawing events. And a drawing event is really nothing more than a piece of text somewhere on the mine panel. I already have a layer here set up for new belt head construction. There's currently nothing on that layer, but I'm going to set that as my current layer, and I'm going to draw a new piece of text. It's just a standard piece of text, and I'm going to tell the program that whenever I get to this point on the main 2 panel, I'm going to trigger the event that starts the belt head for submain 1. So I'm just going to click right there. The height of the text really isn't that important, just give it an arbitrary height. And the rotation of the text, it's also not important. I am going to have this going perpendicular to the center line. And the actual text itself is really not that important. We could type literally anything we wanted to for the text. All that really matters is the layer that the text is on. So what I could call this would be, let's say BH for the belt head, and we're just going to call it -1. So it's just a piece of text on that drawing event -belt head layer. That's really all I need. Then I can just repeat that for as many of those belt head events that I want to create. And I can even just copy the text and place it where I want to. So for example, for this South 1 panel, I'm going to bring that up using my extension tracking snap, place it there. And I can change the text if I want to. I could call this BH-2, or I could call it BH-1. Again, the text really doesn't matter. It's just there kind of for a mapping purpose. So that's just a very simple example of how we can insert those. And they don't have to be on the center line. I do want to mention that as well. I've got another layer here for some overcast points. So those might be lining up with entries in the panels. And all that matters is just that these pieces of text are on a known layer. And as the program goes through this main 2 panel, whenever it hits OC9 or OC8, I can either make that trigger downtime, or I could just report it out, hey, you ran into this overcast construction, and I could make it as simple as, during this month, we're going to have to create how many overcasts. So there's a lot of things you can do with the drawing events. Just with those 2 examples, I'm going to set up, grab the name of that layer. I'm just going to copy that, and let's configure the belt heads. So we're going to go back to the Timing Project Manager and go to the settings. I'm going to create a new drawing event type. I'm going to add one in here. The event key, you can call this really whatever you want. I tend to keep the event key the exact same as the capture layer. For the description, we can just say construction of belt head, something just like that. Next, I've got the productivity effect, so I could make this trigger some downtime. I could also make this trigger uptime for a unit. Or I could say this is going to cause someone to continue working, but they're not actually going to produce any key material. So for example, if a continuous miner crew has to be pulled off to work on a longwall move, something like that, that would be an example where they're still working, but they're not producing. I can set the event delay length in shifts. So for example, if I really don't want this to have any impact, I just want to count, I could set that down to a 0. And what I'm going to do here, just for an example, I'll say it's going to take 1 shift to construct the belt head. But obviously you can change that to any length of time that you like. There is an option here to make this affect additional units. So for example, as continuous miner 1 runs through this panel, whenever it runs into this drawing event, I can make it do something to continuous miner 2. So I could highlight continuous miner 2, and this would affect both CM1 and CM2 now. An alternative, I can make this only affect the additional units. So as the miner is working through this panel, I can make CM2 have some scheduled downtime. So just a simple example there. What I'm going to do here though, I'm just going to set my event delay to 0. I just want this to simply count how many belt heads am I going to have to construct during that month as I'm preparing for additional production. And I'll click OK. I can see that's set in there and I'm good to go. And let's add one more. For this one, I'm going to just call this the overcast. And actually I can just pick the layer name off the list here. So I'll just say this is construction of overcast. And again, I'm not really worried about trying to insert a delay here, so I'll just set the delay length to 0. And we'll say OK. So that's really all that we have to do to define these drawing events. Again, the program is just going to look for a piece of text on a specific layer. Doesn't really matter what the text itself is, but this is just an easy way to make the program count certain events for us. So that wraps up everything that we need to discuss for a basic run through of the Timing Project Manager. Again, you can always go back and make changes to this to update your mine plan. So in the next video, I'm going to be talking about actually using the Timing Project Manager and all the panels that we've drawn so far to actually calculate the timing for this mine. We'll evaluate some results and then we'll cycle through it iteratively as needed.